evaluate 0 to 4 square root 2x plus 1 dx. So there is one little catch in these. You do it the exact same as yesterday, but because it is a defined integral, you have to watch those numbers that are defined. So the 0 and the 4. What is on the sticky note? It's on the light. Okay. I'm seeing things. It's fine. 8:05. Yes. Which the test will correlate the fact that class isn't as long.
Are you sure?
I made it. Okay. All right. So we have 0 to 4, 2x, square root 2x plus 1 dx. So what do I want to change? Or what do I want to make u? 2x plus 1. And then du equals 2 dx. And then I'm going to have to just replace the dx. I'm going to divide by 2. Bless you. And I get 1/2 du equals dx. And that's all the same. So we can still go 0 to 4 square root 2x plus 1 dx equals, that's a 0. Equals, now I can't put 0 to 4, that's the catch. I can go u to the half, and then 1/2 du to replace the dx. And I can bring the half out here instead and not have it here. That hasn't changed. The catch is the numbers. So we have 4 and 0. Do you see that? But that's the values of x, is it not? So can I write 0 and 4 when I have u's? No, I have to find the correlating u's that go with that. So there's an extra step when it's a defined substitution. So I'm going to go down here and I'm going to go u equals, and I'm going to plug in the first one, 0. 2 times 0 plus 1. So it's actually 1 when x is 0. So I put a 1 down here. And then I'm going to plug in the 4. U equals 2 times 4 plus 1, which is 9. And I'm going to put a 9 up here. Do you see how I have to get the corresponding u's that go with the x's? That's the only extra catch. Now, we actually, I'll rewrite it so it doesn't look so stupid. So we have 1/2, 1 to 9, u to the half du. Now you don't have to go back and put the x in once you've integrated it, because you have the x values, you change them to u's, correct? So all we have to do now is integrate the u and then plug in the 1 and the 9s and we're done. You don't have to bring the x back. You don't have to bring this 2x plus 1 back. Okay? So we're going to go 1/2. The antiderivative, or the integral of u to the half, you add 1, you get 3/2. And then you divide by 3/2, which is multiplying by 2/3, plus c from 1 to 9. And now I can just plug in, right? I don't actually have to bring the x back. It'd be 2/3. And this is the square root of 9, which is 3 cubed, which is 27. 1, that's negative 2/3. 27 divided by 3 is 9. 9 times 2 is 18. So I'm going to get 1/2. 18 minus 2/3. And you get 26/3. Now remember, if you have a calculator, you should be able to check these, right? Every single one. Just type it in. This here you'll get 9/2 minus a third. 9/2 minus a third. Yeah, it's an integral. Any integral symbol you can plug in and check.
What if it's,
If it's an indefinite integral, you can't plug it in. There's nothing to plug in. But you could still check your answer, because technically you could try and do it as a defined and then check the answer. Yeah. You don't have an endless amount of time on the AP exam, though, so you're probably not going to have time to do that. Okay.
man, who cares about it? I'm talking about
Example 8. Evaluate (1 to 2) dx over 3 minus 5x all squared. How could I rewrite that? Usually with the dx on top, it confuses people. 1 over that, and then times dx, right? It's the same thing. Okay, you try this one.
you have like a negative, you get a negative 1, this is a negative, so like,
Just wait, I don't know exactly what you're saying. So when I fill in the u's, I'm going to get 3 minus 5 times 1, which is going to be negative 2. So that's going to go on the bottom. And then I'm going to u equals 3 minus 5 times 2, which is negative 7, which is going to go on the top. And I know that they're backwards, and that doesn't matter. It matters that if in the original question they were backwards, you take it out and make it be a negative 1. But you don't flip it and be a negative 1 here. This original question was just fine. So in substitution, that's the only place where you will not flip-flop them and make it negative in the middle of your substitution. If the original was 2, then 1, I would take a negative 1 out, flip it to 1 to 2, and then carry on. But not throughout the middle of substitution. You're just going to plug it in. Okay, so we're going to go negative 1/5. This is u to the negative 2. When I add 1 to it, it's actually u to the negative 1. And then it's going to be divided by negative 1, or multiplied by negative 1, plus c, negative 2 to negative 7. So we're going to get negative 1/5, negative 1 times negative 7 to the negative 1, minus negative 1 times negative 2 to the negative 1. So I get negative 1/5. And then this is going to be negative 7 to the negative 1 times negative 1. Maybe I just got an answer. It's 1/7. And this is a negative 1/2. And then you get 1/14.
so it does.
I didn't know what you asked. I didn't understand, so I thought you'd stop me. What?
You have to square the u.
Negative 1 in front of the negative. Because you're filling it into this formula. Negative 1, u to the negative 1. So I'm going negative 1. Make this positive 1/5. Yeah, that'd be fine. Yes, but you'd have u to the negative 1, and then you still have to plug that in. But you'll get the same answer. These will just be opposites. So this would just be negative 1/7. This would be positive 1/2. And this would be positive 1/5. So you end up with the same thing. Okay. Last one, example 9. Calculate. Okay. It's real awkward.
You know, don't put a pencil sharp. I still got to sharpen it.
All right. Good talk. What are we going to change here? Remember, you have to pick one of them, that when you take the derivative of it, you'll get the other half. So if I pick x, I take the derivative of that, I get 1 dx. Not helpful. But if I try ln x, take derivative of ln x, what's derivative of ln x? 1 over x dx, which is the entire rest of the thing. So which one am I going to pick for you? You guys, remember I said I'm going to miss some things? I think it's becoming harder to figure out what those things are going to be, but I'll keep thinking. Eventually I'll come up with something. I'm kidding, Alexa.
Name one thing.
I'm going to miss coming to period 1 and having your happy faces here. Except Seamus, he's just, talking under his breath with all the nasty things. No, you just smile all the time. That was a joke. I wouldn't have called you out on something that was real.
Really?
Really. Okay. Do the question. Answer this. So, we have u equals ln x. Quiet, please. Du equals 1 over x dx. So it basically just becomes, we'll see this in a second. I'm going to rewrite it. 1 over e ln. If you guys are freaking out, I'm rewriting the question because I don't work my questions on the question. Everyone is calm. Like Beauty and the Beast. It just sounded like I felt like I was in Disney. Okay. I did nothing. I rewrote the question. Chillax. All right. Calm yourselves. Okay. So ln x is u, and 1 over x dx becomes du. So we just have u du. Easiest one ever. Okay. You do you. Exactly. Thank you. Thank you, substitution rule. Okay. U equals ln of e, and then u equals ln of 1. So we have ln of 1, and we have ln of e. Should we write them like that? Okay. What is ln of e? 1, because it's log base e of e, which is 1. What's ln of 1? Because e to what power is 1? 0. Dun, dun, dun. Okay. So we're going to get the derivative of u, which is, the antiderivative of u, which is 1/2 u squared plus c 0 to 1. So we're going to get 1/2 times 1 squared minus 1/2 times 0 squared. So it's going to be perfect question to have in a no calculator section on the AP exam because it's easy to do without your calculator. You need to know the rules that ln e is 1 and ln 1 is 0, etc. Okay? Now, the question for this. What? I wasn't even whining. I said, oh no, I'm getting homework. You didn't see it coming. Okay? I knew it was coming. You saw this. You saw it sneaking up on you. And a new level. We went to a new level again.
Okay, you're making fun of me for lining up those eyes. I'm really complaining about the giant rainbows and surfboats.
I am. I've never seen you as a meeting. I haven't seen there either. I mean, yeah. You're in spirit.
Okay, page 441. Page 441. 61 and 63. And then, who are you? And then page 444. Yes, that's what I call it. Never heard of such, but okay. Okay, 5 and 8. Try this out. I want you to determine the area under the curve. F of x equals 16 minus x squared on 0 to 4. And I'm going to do 4 subintervals. And what do you think I'm going to ask you to do? A. Left.
Left, right, and trapezoid.
Middle.
Nope, there's 4. Yep.
Left, right, middle, and trapezoid. Wait, this is what you saw?
I know you could be like.
It's an addiction. I try and spell it wrong every time.
Why?
Yeah.
Can I spell it both ways?
No, it's illegal the other way, but I just really like it that way. I don't know why.
This one, the only reason I have the Riemann ones are I forget how I'm supposed to like format it before it's right.
It's when you go, you do the sum, and you do I equals 1, and this one would be 4, because it's subinterval 4, and then FUI, change an F.
It's always FUI, right?
I. This is this I.
That means we're going up by one, right?
Yeah.
Or-
Well, you're going up by whatever the subinterval would be.
Yeah.
No, you're going from 1 to 4 partitions, and then you're doing the little partitions, yeah. Okay, there's your question. I want left, right, midpoint. Trapezoid. So, left Riemann sums. We still have to figure out the change in x for all of these. So the change in x is going to be, this is my A, this is my B, that's my N. So I'm going to go 4 minus 0 divided by 4. So I was really nice and I gave you 1. Okay? Then we know that I like doing a number line, so I know what my values are. So I start here, it's 0, then 1, 2, 3, 4. So those are my options that I'm going to be having for my F's. Whether I'm doing left, right. For midpoint is the only one that's a little different. Midpoint, I would get 0.5, 1.5, 2.5, 3.5, right? That's the only one that's going to be a little different. But that number line helps me for all of them. Okay. So I'm trying to find the sum. We'll go, okay, so we go 16 minus x squared dx. I don't know how to This is really bad. I don't even know how to describe it. It's the integral symbol. It like blanked on my head as to which direction it went. Oh, guys, I'm getting old. That was scary. It's just an S. That's weird, but it's still an S, and I really wanted to draw it backwards in my head, and I couldn't adapt. Okay, so we're from 0 to 4 to 0. It's just an S. But I really struggled. I wanted to write it backwards. Yeah, I do. COVID, stay away. Okay. Anyways, so what we can do is we could do change in X. So remember, it's length times width, length times width, length times width. And the change in X is my width, correct? So I could either go change in X times F of, I'm doing lefts, change in X times F of 0 plus change in X times F of 1 to change in X F2, change in X F of 3. Or I can just write the change of X out front, correct? And write all the X, because it's the same thing. So I could just go change in X. I'm going to do our something first, sorry. I equals 1 to 4 F UI, change in XI. Okay, so we can just do the change in X in front if we want to, which is 1, which isn't going to do anything anyways. And then we do, I'm going to write out the formula so you have it at least that you can use it for yourself tomorrow. So change in X, then we can go F of 0 plus F of 1 plus F of 2 plus F of 3. Why didn't I choose F of 4? Because it's left and F of 4 is the right. So I'm going to use it on the next one. Change in X is 1. F of 0 is what? 16 plus F of 1 plus F of 2. Oh my goodness. What's F of 2? And then 7. When you add them all up, you get?
50.
You're so funny. 50?
Yeah.
Better than 183 or whatever. Okay, so it's the same thing for the next one, but the only difference is we use the right. So we won't use F of 0, but we will use F of 4. So it's going to be 1, and then I'll show the formula again. Change in X, F of 1 plus F of 2 plus F of 3 plus F of 4. So it's going to be 1. F of 1 is 15 plus 12 plus 7 plus what? 0? And what do we get? 30. What? It's 27 plus 7.
34.
You guys should all have this worked out. It scares me that you Okay.
Yeah, 30.
Well, they want to see the calculations for F of 1 and F of 2.
Yeah. Okay, midpoint, we're going to do change in X, and then we're going to do F of 0.5 plus F of 1.5 plus F of 2.5 plus F of 3.5. And so we get 1 times, what are these? Quickly, I want to get through the whole thing. Okay, then trapezoidal rule, we have to know the formula. We would do area equals, if we want, from 0 to 4, what was it, x squared. Oh my gosh, I'm struggling. I don't know why. It's because he reset my board. He just threw it all out. Come on, Monty. Okay. So we're going to get 1 over 2, because it's change in x over 2. And then we do f of 0, 1 plus 2f of 1 plus 2f of 2 plus 2f of 3 plus f of 4. Your endpoints only happen once because you are actually only using that arm once, right? Okay. So we get 1/2 f of 0 is 16 plus, 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 plus. What do we get? Okay. Then the other question I asked you was determine -1 to 2 f of x dx, where f of x is a piecewise function, x plus 1 if x is less than 0, x squared plus 1 if x is greater than or equal to 0. Okay, so we're going for, if it's less than 0, we use x plus 1. If it's greater than 0, we use x squared plus 1. So if you use it as a short integral, it's a piecewise function, right? So we go -1 to 2 f of x dx equals, and now we're going to go from -1 to 0, and what am I going to use? X plus 1 dx, and then I add to it 0 to 2, and then use the other function, x squared plus 1 dx. Okay, what's the antiderivative of x plus 1? 1/2 x squared plus x plus c. -1 to 0. And then this one's going to be 1/3 x cubed plus x plus c, 0 to 2. So we're going to get 1/2 times 0 squared plus 0 minus 1/2 times -1 squared plus -1. So it's that one. And then here we're going to get 1/3 2 cubed plus 2 minus 1/3 0 cubed plus 0. What do we get? Pardon? 31 over 6.
31 over 6. I got it positive.
I got big positive.
Solves all problems. Okay. Determine the average value. What is the average value formula? Y bar equals 1 over b minus a. Then what do I get? Equation. F of a. Yes. But then we do what? I was like, A to B. What were you? I get what you're saying. And then she's like, yes. I was like, I feel you, but I don't understand what you're saying. Okay, so the average value of f of x equals square root x over 0 to 4. So we'd fill in y bar equals 1 over 4 minus 0, 0 to 4, square root x, which I don't want to write it as square root x. I'm going to write it as x to the half, dx. So we're going to get y bar equals 1/4, and then x to the half becomes x to the 3 halves. Divide by 3 halves is 2/3 in front, plus c, 0 to 4. So we get y bar equals 1/4, 2/3, 4 to the 3 halves, minus 2/3, 0 to the 3 halves. 4 to the 3 halves is 2 cubed, which is 8. 8 times 2 is 16 over 3. So I get 1/4 times 16 over 3, which is 4/3. Oh, there's no extend page. I've run out of extending. I will have to change page. Okay. Then we have to determine the distance and the displacement. Net distance and displacement. So displacement's the easier one. So the displacement, what do? We go from 0 to 6, and we just do the integral, right? We just integrate it. So we go, the antiderivative of 2 squared is 1/3 t cubed minus, and then this be t to the 1 be t squared divided by 2, so I'm going to get negative 1t squared minus 8t plus c from 0 to 6. And then I get 1/3 6 cubed, which I can't do in my head, minus 1 6 squared minus 8 times 6 minus, it's all going to go away, but I'm going to write anyways, 1/3 0 cubed minus 1 and 0 squared and 0. Gone. What do I get? (72 minus 36) okay, equals -12. Okay. Heard you speaking, but my ears were not hearing what you were saying. Okay, net distance. Net distance, we have to do this piecewise function. So the first thing we have to do whenever we're finding net distance is find the x-intercept. So I'm going to go 0 equals t squared minus 2t minus 8, which factors into t minus 4t plus 2, which gives me t equals -2 and 4. So if I went to sketch this, I know it's a concave up parabola. I know I have -2. It's going to be the most accurate graph you've ever seen. Don't you worry. It's going to be amazing. Concave up. So great. Okay, do we actually care where the minimum is? We don't care. We just need to care that this part is going to have to pop up. Correct? So it's our middle part. If it was concave down, our arms would pop up. That's the only difference. Okay? So we know we can make our piecewise function. We know that we have f of v of t, not f of x, we have v of t equals, the arms follow the actual formula of which we were given, which was t squared minus 2t minus 8, and it's from 0 to 4. Why not -2? So what happens actually? Drop it off.
Is that not correct?
It's not incorrect, but what do I need to do? Make it that one. Negate it. That I'll take. I was like, make it that one. So we're only negating, we actually only have one piece, don't we? Because the whole piece we have has to do this. Oh gosh, it's going to have to do this. I don't know why I'm really making it a parabola in the middle. We'll pretend it's not symmetrical. I don't know what's happening. Something like that. This is just the whole, like, I sketched it so well, now I don't even know what to do with myself, because how can I get better than that? Okay, so it's going to be something like that, because it has to be symmetrical, so it has to curve before there has to be some sort of, like, vertex. I really wanted it to not, but that's not true. Because if I'm from 4 to -2, my vertex is going to land in somewhere here, right? Okay, so it's concave down the whole way, we agree? So technically I have something stupid like -t squared minus 2t minus 8. And I'm done, right? No, I'm not. Why? Because I need to go from 4 to 6, which is actually just the math. See, it gets better and better as time. So it's the original. So what are we just going to have to do? 2 separate integrals, 2 separate areas, and then do what with them? And when it's distance, these should always be what? Positive. If you get a negative, question yourself. And by question yourself, I mean you're wrong. Go back, try again. Okay? That's a good, bad, or the other. Okay, so we're going to go from 0 to 4, and we can distribute the negative t in if you want, or keep it out. It doesn't matter. I'm going to distribute it in. Plus 4 to 6. We're at the BT. Okay, so when I go to the antiderivative of this one, I'm going to get -1/3 t cubed plus 2 divided by 2 is 1 t squared, and then plus 8t plus c, 0 to 4. Plus 1/3 t cubed minus t squared minus 8t plus c 4 to 6. So I'm going to get negative 1/3 4 cubed plus 4 squared plus 8 times 4 minus that with zeros just to prove a point, but it's going to do nothing. Area 1 plus positive 1/3 6 cubed minus 6 squared. Now, if this is a written response section on the AP exam, remember I told you you need to show this top part, but then what can you do? Just use your calculator and get answers. You could do this one, get an answer, this one, get an answer, add them, give me an answer, boom. Written response, or any place in that test, if it's calculator, you can use your calculator, right? So in the written response, if this is the calculator spot in the written response of your AP exam, you can do this, you can do this, you can do this, and then just this. If it's tomorrow, I'll say algebraically, and you have to show it up. Okay, so what do we get? The entire thing. 80 over 3 plus something. What is that? 41.3. What is this a fraction, isn't it? Pardon? Over 3? 3. Okay, and then our last one. I specifically gave this one because you couldn't get it immediately with L'Hopital's rule. You had to remember that I told you that if you can't get it in the first one, you just keep doing it over and over till it works. So when I take the derivative of the top, now I don't do quotient rule. This kills me. I see people like have this massive quotient rule going on, and I'm like, that is not what I taught you. You just differentiate the top, done. Differentiate the bottom, done. And then you fill it in and see if it works. So the derivative of sine x is what? Cos x, and the derivative of negative x is? Derivative of x squared is? Oh crud, I plug a 0 in, my denominator is 0. That doesn't work. Keep going. Limit as x goes to 0. What's the derivative of cos? Negative sine x minus 1 over 2. What do you mean? It's not there. Okay, negative sine times 0. That is not sine times 0. That is sine of 0. And then 2. Pray for me. What is sine of 0? It's not 1. Pray for the person who said 1. And the answer is 0. We'll pray for me and the person who said 1. We will not judge. Not judge.